Now, this is example 3, where we are told to verify the identity, the product of secant squared x minus 1 and sine squared x minus 1, and prove that it equals to negative sine squared x. So, as usual, we have to determine which side of the equation is the more complicated side, and that's the one we're going to go ahead and manipulate so that we can kind of simplify that expression and then make it turn into the other side of the equal sign. So, in this case, the left-hand side is the more complicated side of the equation. And if you're referencing the textbook, you might notice that this exact question is not the exact question that's provided as example 3, because in reality, this is the checkpoint question that follows example 3 in the textbook. But I just wanted to choose a different example to work with so that you had more references to look back to if you're still confused about how to do a problem like this one. So with that in mind, let's just keep moving forward. Now we're choosing the left-hand side to actually manipulate. So let's copy it down and work with it. We have the product of secant squared x minus 1 and sine squared x minus 1. And we're trying to figure out how do we manipulate this expression to turn it into negative sine squared x. So we're going to have to use some of the trigonometric Pythagorean identities here. In particular, the ones we'll tap into are sine squared u plus cosine squared u equals 1. And also simultaneously, we are going to be looking at the product of 1 plus tangent squared u equals secant squared u. Now, these two are going to be useful because from this equation, from the first one, we can actually rearrange things a little bit and make it turn into this expression we have here. So if we were to just subtract the 1 from this side and move the cosine squared u to the other side, hello, oh boy, this equation will turn into sine squared u minus 1, which is equal to negative cosine squared u. So this that I've highlighted or underlined in purple is actually equal to negative cosine squared x. Now we're keeping that in mind because we're going to use that in the next step for the substitution. But now I'm going to take a look at the next Pythagorean identity to figure out what expression can I use to sub out this first portion of my product. So if I just subtracted 1 from both sides of my equation here, I'll get exactly what I'm needing to substitute, which is just going to be the tangent squared of u. So we're going to substitute whatever we were able to determine here. So this, this becomes negative cosine squared x because the variable we're using is x. And this side becomes tangent squared x. So let's continue and work the rest of the problem. So now the product turns into tangent squared x as the first term times negative cosine squared x. So in reality, I'm going to go ahead and erase some of the work here so we can make some room to work on the rest of the solution. So now we have tangent squared x times the negative of cosine squared x. And tangent is technically the quotient of sine over cosine. So if we had tangent squared, then that would have been sine over cosine squared for each case. So the first term I'm going to rewrite as sine squared x over cosine squared x, keeping in mind that this entire fraction is still being multiplied by negative cosine squared x here. And the cosine squared x's cancel each other out. This leaves behind only this negative, which multiplies with the sine squared x, giving you the product of negative sine squared x. And that's exactly what we had in the original problem. We were now able to take the left-hand side of our equation and turn it into the right-hand side because this is exactly what we got as our final version of the equation. And this video has been accompanied by my cat, Sarabi, so let's just give her a wonderful shout out. Okay, goodbye.